We're going to finish looking at finite geometric series, section 11.4. We looked at it yesterday and came up with or previously, and looked up at a formula. And then after that, we'll look at section 7.5, which is our infinite geometric series, meaning there's not an end to them. That might seem strange that you could find the sum of a series like that, but certain ones you can. So we'll get to that. So if we look for section 11.4 for a finite, our formula was a1 minus a1 times r to the n over 1 minus r. Now previously in, when we talked about geometric series or sequences, to find the nth term, a sub n, it was a1 times r to the n minus 1. And if I look at this, and I look at this right here, okay, they look pretty similar, except really there's one more r here than there is here, because there's n minus 1 r's here, and there's n. So if this n was 10, there'd be 9 of these here. Be r to the 9th instead of r to the 10th. So really what this is right here is a sub n, a sub 1 times r to the n, is really a sub 1 times r to the n minus 1 times r, because we add those exponents. And so really what that is here's a sub n, oops, and I can't even do that. Here's a sub n. So really this part right here, a sub 1 times r to the n, is just a sub n times r. And so this formula can be altered for some examples as well, in the fact that s sub n is a1 minus a sub n times r over 1 minus r. So if I don't know what n is, if I don't know how many terms it is, I can still use this formula right here. And so that's what I would do. So let's look at an example of that. Let's say I gave you that a sub 1 was 1, a sub n is 2,187, and r is equal to 3. So if I tried using this formula up here, I would have to know what n is. And so I'd have to go back to this formula up here and try to figure out what n is. It's really hard to do, and it's long to do. Having this other formula now actually is a lot easier, because I have a1, I have a sub n, and I have r. I have everything I need. All I got to do is plug it in. So s sub n is a1 minus a sub n times r over 1 minus r. And then you take your calculator, and we just go put that in. And again, make a fraction. Oops, I guess it helps to turn it on. Alpha y equals a fraction. We want 1 minus 2187 times 3. And then on the bottom, 1 minus 3. And the answer is 3280. So sometimes we can find out by using this alternate form of the formula. Okay? All right, so that finishes up section 11.4. Infinite geometric series missed the r in here, is something like this: 1 plus 1/2 plus 1/4 plus 1/8, where this just keeps on going forever. Stuff keeps getting in the way. Okay? Where that just keeps going on forever. Now you would think that you wouldn't be able to add that up. But again, what ends up happening is out here at a certain point, it becomes pretty negligible compared to what you've added up to that point. But you can't really use the formula that we've used previously because I have to know how many terms there are or what the last term is. And this doesn't have a last term. And so in some cases, and this is what you have to determine first, is first you find out what is the common ratio for the problem. And again, you just take a term and divide it by the one before it. So if I did 1/2 divided by 1, my common ratio is 1/2. Okay? Series are said to either converge or diverge. And what converge means is they close in on a particular value. Diverge means they expand out and never close in on a particular value. Okay? And series converges if it does this right here, if the absolute value of r is less than 1, meaning that r is a fraction less than 1, or it could be a negative, like a negative 1/2. Can't be a fraction bigger than 1. So if once you find r, if you take the absolute value of that, and it's less than 1, the series converges. And so that's how you can tell if it converges. So I know that this converges. If I had one like 5.5 plus 6.05 plus 6.655 plus so on and so forth, we want to know, does that converge or diverge? Converge. So this one converges. Converge or diverge. Which one does this do? Right, we'll circle the right one. So what I do is I find what r is. R is going to be a term divided by the one in front of it. So if I take my calculator and I go 6.05 divided by 5.5, I get 1.1. The absolute value of 1.1 is equal to 1.1, which is greater than 1, isn't it? That means that this series diverges. And there is no sum when it diverges. When it converges, there is a sum. So let's see if we can figure out how we find the sum of this one. And so there is a formula for it again. We can go through and figure out. I'll start out here again by putting that one down. 1 plus 1/2 plus 1/4 plus 1/8 plus dot, dot, dot. Okay? The formula for the sum of an infinite series that converges is S equals A1 over 1 minus R. And again, I'm not going to go into detail about where that came from. You can look that up. Be a good research problem for you to figure out. So what I need on this is I need A1, and I know what R is. But I need to know that this converges first. So again, you find out what r is, find the absolute value of that, and if that, since that's less than 1, this converges, so I can find its sum. Then it's a matter of just plugging in here. A1 is 1, r is 1/2. So S is going to be 1 over 1 minus 1/2. And again, you just take your calculator. We're just going to make a fraction. Oops. Alpha y equals a fraction. We're going to put that in just like it is. 1 over 1 minus, and you can do a fraction there if you want, or just do 1 divided by 2, or do 0.5. It doesn't make any difference. We get that the answer of that is 2. So the sum of that, if you were to add up 1 plus 1/4 plus 1/8 plus 1/16, so on and so forth, it would add up to 2. Okay. One more example of that would be if I gave you something like this. -3 minus 4 minus 16 thirds minus 64 ninths. Dot, dot, dot. Now notice this. Notice these are all negative. So the answer is going to be negative. But again, first we find what r is. R is a term divided by the one before it. Negative 4 over negative 3, which is 4 thirds, which is 1.3 repeating. We find the absolute value of that, which is greater than 1. That means this diverges. Shoot, sorry about that. Take a term and divide it by the one before it. 4 thirds, the negatives cancel out. I get 1.3. Take the absolute value of it is this. That's greater than 1. So this is diverges. So no sum exists. We can't add those up because the number just keeps getting bigger and bigger. Okay. One other type problem then is that using sigma notation. So if I gave you one that had sigma notation and it said k was equal to 1 to infinity of 3/4 times negative 1/4 to the k minus 1. So again, when it's written like this is a sub 1, this is r. And again, for our formula, it is s equals a1 over 1 minus r. All we have to check to make sure this has a sum when it goes to infinity is that the absolute value of r, negative 1/4, the absolute value of that, well, that's positive 1/4, and that's less than 1. So that means it converges. Since it converges, that means there's a sum, so we can plug it back in here. S then is going to equal a1 3/4 over 1 minus r, which is negative 1/4. And again, we can just take the calculator and we're just going to put that right in there. Just going to make a fraction. 3 divided by 4 over 1 minus parenthesis negative 1 divided by 4. And the answer is 0.6. If I wanted that as a fraction, I would just do math. Oops. I could do math and choose number 1 right there. Fraction. And it gives me the answer is 3/5. Or s equals 3/5. I don't care. You can leave your answer as the decimal. That's fine with me. All right. So that should do it for the video for today. Again, try the problems. Let me know if you have questions.